Hello viewers, welcome to K-Diagnostics, Dio here. Today we have a 2015 Mercedes Sprinter with a 3.0 liter. The customer complaint on this van is that the air conditioning does not work. So the first thing we're going to do is we're going to go inside the van and confirm the customer's complaint. After confirming the customer's complaint, then we will talk about what directions we're going to go to fix this. So let's go inside the van and confirm the customer's complaint. Alright, so we're gonna confirm the customer's complaint. I'm gonna start the van. As you guys could hear, the van is running. So now let's turn on the air conditioning. So the air conditioning is on now. I'm going to increase the blower motor speed. What? So nothing is coming out of these vents. So there's no air coming out of these vents. So I am increasing the blower motor speed. Nothing. So it looks like our blower motor is not blowing any air out of these vents. And I think the customer was mistaken when he said the air conditioning is not working. I mean, it depends on how you look at it, but I believe the air conditioning is working in this car. The blower motor is not blowing any air through these vents, so there's no air being blown through the evaporator behind the dash. So that's why he said that the air conditioning is not working. So we are either dealing with a defective blower motor or a defective blower motor regulator, or maybe a wiring issue, or it could just be a fuse, who knows. So right here, customer's complaint confirmed. Okay, and this is gonna steer me towards a blower motor or a blower motor circuit. We have to see why this blower motor is not blowing any air, and I believe the air conditioning is just fine. Okay, so if the blower motor was working, you guys could hear it. It's not blowing any air. I'm not feeling anything. So I'm gonna turn off the van so we can talk about our plan of attack. Let's see how we're gonna attack this. Alright, so the van is off. How are we gonna fix this? This should be, hopefully this is just gonna be a quick one. Well, there are a couple ways we can go with this. We can connect the scan tool to the van to see if we have any trouble codes in the air conditioning control module. Or we could also look at the wiring diagram to find out how this blower motor is wired. And we can also check a fuse and see how the regulator for this is wired. I think it's a 5-wire blower motor regulator. And there's a power and a ground, and then there's a signal coming from the control module. And then the blower has only got 2 wires. And the blower on this one, the front blower, because this has got 2 AC units, there's one in the front and another one in the back. The blower motor for the front AC unit lives right behind the glove box. Okay, so let's stay low-key here. Let's not bring out all the big guns first. I am going to just go to the blower motor itself and do some checks there. We can use a test light to see if we're getting any power and ground at the blower motor. So the first thing we're gonna do, just based on the location and based on how easy it is to get to the blower motor, that's why I'm going this route. So I'm going to remove the glove box, which only has a couple of screws. So let's remove the glove box and get access to the blower motor. And the good thing about this is that the blower motor is just right there next to the blower motor regulator. And I believe it's either the blower motor regulator or the blower itself. So let's go to the passenger side and remove the glove box. And once we get the glove box removed, then we'll get access to the blower motor. Alright, so I'm here on the passenger side, and the first thing we're going to do is we're going to remove the glove box. I already emptied the glove box, so there's nothing in here. And we do have 2 tabs down over here. Let me bring in the light. Alright, so we do have 2 plastic tabs. There is this one and that one over there. So what you need to do, you just have to push them up to release the glove box. Okay, so I'm going to push that one up, and then the glove box is gonna swing down. right there. So what you're doing is just push this up, okay, and then same thing on this one, push this up, and then the whole glove box is gonna swing down. All right, so the glove box, this plastic glove box here, is bolted to this plastic frame, and it's got 3 little tiny torque bolts, and these torque bolts are T25 bolts. So we are going to undo these 3 T25 torque bolts. Okay. Bear with me guys, because this is going to be slightly uncomfortable doing this one-handed while I'm also holding the camera on the other end. So just bear with me here guys. So now we're gonna undo the other one. It drops down, so now let's get this out of the way. I'm just gonna sit this over here. Alright, so we are making progress. So glove box is removed, so now we have to remove this side cover. And this side cover has got a bolt, a tiny little bolt under here. I don't know if you guys can see, but there's another T25 torque bolt over here. So I'm going to undo this. Right, there it is. So here's the bolt. So now I'm going to remove this cover. It just pops off. There we go. So let's get this out of the way. We have to remove these 3 T25 torque bolts. So there's this one, that one, and this one over here. Once we undo all of these 3, this cover is gonna come off. And once we remove this, we'll get access to the blower motor. Okay, so this one comes out. Now we're gonna undo this one. Now we're gonna undo that one over there. Alrighty, so this plastic cover here should come off. Okay, perfect. So I'm just gonna sit this over here, and here we are. So here's our blower motor, and here's our blower motor regulator. Okay, so we are going to test these 2 components, because the component that makes the air, you know, rush out of these vents is the blower motor. And remember, when we were turning the AC on, nothing was happening, so we weren't feeling any air come out of these vents. So we're gonna test these 2 components. Knowing these circuits, this wire here is the red wire, is a power supply. Well, basically at this point, to someone who doesn't know these circuits, you would pull out a wiring diagram so you can find out what wire is what. This black wire here is a ground, okay, and then the red wire here is a power supply, so it's a constant power, okay. And then this little tiny brown, not brown, it looks like, I hope you guys can see this wire right here, this gray wire, is the command coming from the AC control module, okay, the air conditioning control module. This wire, it commands, it tells this regulator to send the correct amount of ground to this blower motor, so that the blower motor can turn at whatever speed that the driver commands it to. Okay, there should be a constant power supply on this wire, and then there is varied ground on this. So this regulator just varies the current flow on this wire, okay, to increase or decrease the blower motor speed. So we don't have to get too fancy. Let's just remain low tech here. This is not really hard to diagnose. I hope it's just gonna end up being a blower motor, which I suspect is gonna be the case here. So the first thing we're gonna do is, let's start by checking the blower motor itself. I'm gonna do that by disconnecting this blower motor electrical connector. So hopefully I can disconnect it while I'm holding the camera. Okay, right there. So here is the electrical connector to the blower motor. Okay, so what we're gonna do is, I'm gonna bypass the blower motor. So what I'm gonna do now, I am going to connect a test light across these two wires. Okay, I'm gonna grab some piercing tools and then pierce these two wires. I'll connect a test light across these wires to see if our test light is gonna light. If our test light lights, then we can call for a new blower, because that would be the end of our diagnosis basically. Because if we have current flow or voltage at this point, then our blower motor should spin, right? So I'll grab the test light and I'll be right back. Alright, so I'm going to use these two piercing tools to pierce these two wires on the electrical connector of the blower motor so we can take some measurements here. I know these two piercing wires make holes in the wire, but I will use some liquid tape when I'm done so I can fix those holes. Alright, so we got our two piercing tools right there on the wire. Alright, so now I'm going to connect this test light to these two piercing tools that I just put here on the wires. And if we have power and ground on these two wires, this test light should light once I connect it to these two piercing tools. So one end of the test light is going to go to this piercing tool, and then the other end of the test light is going to go to the other tool, so the other piercing tool here. So right here I have my test light connected. So now I am going to turn on the blower motor. So basically what I'm doing is I'm bypassing the blower motor with the test light. So the test light is the blower motor now. If the test light lights, we know we have good power, good ground, we have current flow, so our issue will be the blower motor itself. So now I'm going to turn it on. Once this, I don't know if you can tell the difference already, but I was going to say once this test light comes on, it's going to turn blue, and right here it's blue already, and it's a little bit dim. So right here I am turning on the blower motor speed. Once I increase the speed, our test light should get brighter. Do you see that? So our test light got brighter, and when I decrease the speed, it's gonna get dimmer as I decrease the speed. See, it's got dimmer. So our issue, test light went off. When I turn the blower motor speed up to full, our test light lights. So we have current flow, we have power, we have ground. So our issue is our blower motor. Okay, so our test light just confirmed it. So our blower motor regulator is good, but the problem is the blower motor. So I feel confident at this point replacing this blower motor. Okay, we don't have a wiring issue, we don't have a blower motor regulator issue. The problem is the blower motor itself. Alright, so we confirmed that. Let me get this test light out of the way. So there's another test I want to do. Actually, I don't even think if it's important at this point. Is a current flow test. I'm gonna connect this electrical connector back to the blower motor. The electrical connector is connected back to the blower motor. So now I'm gonna bring up my lab scope here, and then I will use an amp clamp around one of these wires to see if we have any current flow. Just watch. I am turning the blower motor on right now and nothing happens. while the blower motor is connected. I'll bring the lab scope. Alright, so I'm gonna set up the lab scope and let's see if this blower motor is drawing any current. Let's go to scope multimeter, lab scope, 4-channel lab scope, and I am on the voltage scale right now, so I'm gonna change that. I could just stay on the voltage scale, but let's just go to the current scale. So let's go to low amps. So let's select the 20 amp scale, and I am going to turn on my amp clamp. I'm gonna set it on the 20 amp mark, and I'm gonna zero it by pressing and holding this button. So right there, my amp clamp is on the 20 amp mark. So I'm gonna clamp it around any of the wires. So I'm just gonna pick this red wire. So I clamped it around the red wire. So now let's see if anything is gonna happen while I turn on the blower motor. So I gotta turn the key on first, and then so right there, I hope you guys can see that line across the screen. That line is increasing and it just went down. Actually, let me increase our time base so we can have more detail. Okay, let me increase it up to a second. We need a longer time base because I want to see that increase in current or increase in the waveform, so we can make our analysis. Right there, did you see that? Did you see that immediate increase? Actually, let me increase my time base up to, let's do 10 seconds. Okay, and your time base, you can just play with it as you go. Yeah, so right there. So I'm gonna pause this here. Do you see this? Do you see this immediate increase in current flow? This means this blower motor is shorted. Okay, we have a shorted blower motor because current flow should increase gradually. It should look like a ramp. It should increase gradually as the blower motor speed increases. It shouldn't shoot up like this. Okay, so this tells me that the blower motor is shorted blower motor. And then our max here, we are, so the peak here is 5.8 amps. So our max amperage, so this blower, once you turn it on, it immediately pulls 5 amps. So 5.8 amps, which is a lot for this blower motor. Okay, so shorted blower motor. The test that we did with the test light, that was definitive enough. I wanted to bring the lab scope in the picture so that we could see how much current the blower motor is drawing. And we're also going to do the same thing with the new blower motor. And I believe the new blower motor is going to be more of a gradual increase in current than a immediate increase as this one is doing. Okay, so shorted blower motor. And you don't have to have a lab scope to do this or to find out if your blower motor is defective. You can do that with a test light, with a multimeter, with basic tools you can do that. But I am doing this with the lab scope just for, I would say, study purposes, I guess, just to see, you know, how a shorted one, how much current is gonna draw versus the new one. That's all. But we didn't really have to do this. I guess just another step that I wanted to show you. Okay, so I will get the blower motor replaced and then we can do a current test again. But I believe once we replace the blower motor, we're gonna feel some air coming out of these vents. So just right here, let me turn this on. So nothing is coming out of here, so I'm gonna turn on right here. So watch. So let's go down here and watch there. See that? So definitely shorted blower motor. Okay, so I'm gonna remove this amp clamp, and here is the new blower motor. It just came in brand spanking new. So I will get this blower motor installed, and then we'll see what happens after we install this blower motor. So now I'm going to remove the old blower motor. So I'm gonna start by disconnecting the electrical connector of the blower motor first. Let's get that out of the way. And this blower motor, so the way you remove this, you just twist it, okay? You twist it counterclockwise like this. You twist it, and actually let me undo this bolt here first. There's a vent tube underneath here. Okay, so you just twist it, and then here it comes. So everything is plastic here. Just work it out slowly right here, and then pull it out, and here it comes. So here is the old blower motor. So I'm gonna set it over here. So now let's install the new blower motor. So you basically just push it up and then pry this tab, and there it is. It's pretty easy, guys. So then you're just gonna line it up like this. So I'm gonna show you the tabs that you have to line up. So basically what we're gonna do is we're going to line up this side. So there's a tab here. Hope you guys can see there's a tab. It's just a plastic tab, and then this base here. So you just twist it. I can't do this one-handed, guys. Okay, so I'm gonna sit you guys over here while I do this with both hands. Alright, so I'm gonna have to twist this with both hands. Alright, so right there. So I had to do this with both hands, guys. So basically what you do, I'm gonna show you here with the old blower motor. So there are plastic tabs here. So there's this one and this one. So what you do is you grab the blower motor from the back and then twist it counterclockwise and then pull up. You push it in, you line up these tabs, and then you twist it counterclockwise to install it. All right, so our blower motor is installed. So now I'm going to connect the electrical connector back up. Right. So the electrical connector is connected. So are you guys curious? Now let's try. I'm going to turn on. So now let's turn on the blower motor. Can you guys tell the difference now? I hope you guys can hear the blower motor. The blower motor is definitely working now. Remember before it was just quiet. Okay? So I just turned it off. So now let's bring our amp clamp back here so we can measure the amount of current that this new blower motor is drawing. Okay, so we're gonna do the same thing. I have my amp clamp clamped around the red wire. Alright, so I'm gonna turn on this new blower motor and let's see what happens. You see the new one, you see the difference. Let me pause this. Can you guys tell the difference on this waveform? There's a huge difference between the one we were looking at first. With the new blower motor, did you guys see the increase in amperage here? But it's not a huge line that went all the way up to 5 amps. Okay, it went up a little bit to about half an amp, and then as I started increasing the blower speed, the amperage also started increasing accordingly. All right, so this is definitely a fix. We made the right call right there. Can you tell the difference? You see how it's increasing right there? So it's gradually increasing. It's more of a ramp. So let's do one last check. And right here, as you guys can hear, the blower motor is definitely working now. I'm gonna hold this piece of plastic here so you can see how it's been blown. Alright, so we made the right call. As you guys can hear, the blower motor is working now. So at this point I'm going to turn off the blower motor so we can wrap up this video. Alright, do you guys see the slide, the nice decrease, the nice slope here on the lab scope? How nicely the current is decreasing down to 0 instead of shooting down. I don't know if I can show you the numbers here. So max, the maximum number here on this new blower motor, the maximum number is 1.77 amps. So this blower motor is drawing around 1.7 amps. Okay, way lower than the other one, the old blower motor. Okay, so the other blower motor was definitely shorted. Alright guys, so I am going to end this video right here at this point. I am gonna remove this amp clamp and put the cover back on, and then the glove box, and putting everything back together is just a reverse process of the removal process. Okay, I don't think I'm gonna film putting everything back together. It's pretty easy, and I'm sure once I take it for a test drive, the AC is gonna work and everything is just gonna be fine. The problem wasn't the AC, the problem was just the blower motor. Alright, so I'm gonna leave it right here. This is how you diagnose and replace a blower motor on a 2015 Mercedes Sprinter with a 3.0 liter. Basically on most of these Sprinters it's the same process, whether it's the 3.0s or the 2.1s. You know, most of these Sprinters, the blower motor is located behind the glove box, and removing them is basically the same procedure. Okay, you can do this with a test light. You don't have to have fancy tools, you don't have to have a lab scope, but I just wanted to see the amount of current that the old blower motor was drawing versus the amount of current that the new one is gonna draw. So the lab scope part wasn't really necessary, but I just wanted to do it. You don't have to have the lab scope to do this or to fix this. Okay, so I hope you like this video. If you do, give it a thumbs up. If you don't, give it a thumb down. But if you do, you gotta tell me why. Okay, if you have any comments, questions, leave them in the comment box. If this is your first time here, subscribe to my YouTube channel, K Diagnostics. While you're down there, ring the bell so you can get notified every time I upload a new video. Thanks for watching, guys. See you next time.